For a lot of today's tech challenges, Kubernetes is specified as the answer. But let's cut through all the hype, shall we? Today we're going to look at exactly where Kubernetes truly shines, from supercharging your microservices to powering AI training clusters. The first use case for Kubernetes is working with microservices. You know the drill, you've split your giant monolith into 40 tiny independent services, each with its own release cadence and its own little quirks. The challenge? Manually keeping track of who talks to whom, who needs more RAM, or who just decided to take an unexpected nap in production. Kubernetes fixes this by giving every single microservice a consistent, reliable home. We're talking about containers neatly wrapped into pods, pods logically grouped into deployments, and a built-in DNS that lets them find each other. Add in smart readiness and liveness probes and you get zero downtime rolling updates. Kubernetes can also swap out old versions for new ones, like a master DJ mixing tracks, making your audience never even know the beat has changed. Next, let's talk about autoscaling. So if you have a traffic spike, Kubernetes has your back. Its horizontal pod autoscaler constantly watches your metrics in real time, CPU, memory, or even custom Prometheus numbers. When things get busy, it automatically spins up new pods before your users even notice a hint of lag. And if those new pods start maxing out your existing servers, the cluster autoscaler then steps in, politely asking your cloud provider for more nodes so you don't run out of room. Then when the wave passes and things calm down, it intelligently scales everything back down. And if you add in KEDA for event-driven scaling and Carpenter, your cloud build shrinks faster than ice cream on a summer sidewalk. Use case number 3, multi-cloud and hybrid deployments. Let's be honest, companies hate vendor lock-in almost as much as they hate downtime, and Kubernetes offers a brilliant escape. It has a uniform API. Whether your nodes are living in AWS, Azure, or Google Cloud, or even the server room down the hall, Kubernetes speaks the same language. You package your applications into containers, ship the same YAML configuration to every cluster, and boom, you're done. Fourth, let's talk about CI/CD integration. So the majority of the CI/CD pipelines you're using can leverage Kubernetes native workers. Apart from that, there are CI/CD tools like Argo CD, Flux, Tekton, or even Jenkins that run natively on your Kubernetes clusters, automating all CI/CD processes. This means that you can create ephemeral test environments, your pods are spinning up, tests run, and then your pods vanish, and rolling updates and canary deployments become a breeze. You can ship a new version to just 5% of your traffic, let your automated checks bake, and then if everything looks good, promote it to 100%. Fifth on our list, we have batch processing. Think about it, ETL jobs, nightly reports, those resource-intensive machine learning feature extractions, and Kubernetes treats them exactly like first-class citizens. You simply create a job resource, and it will run pods until a set number succeed, then cleanly shut them down. Need it to run every week? Wrap it in a cron job, and you can finally forget about wrestling with Linux cron tabs on a bunch of random VMs. And Kubernetes handles all the retries, orchestrates parallel workers, and enforces resource quotas so your critical data pipeline doesn't accidentally starve your shiny web frontend. Before diving into the next use cases, don't forget to like the video and subscribe to get notified when new videos come up. Sixth on our list, we have high availability and disaster recovery, and this is where Kubernetes truly shines as a resilient platform. It automatically replicates pods across nodes, across different AZs, and in advanced setups, even across entire clusters. Think about it, multi-cluster configurations with robust etcd backups and Valero snapshots mean that if an entire cloud region decides to take an unplanned vacation, you can restore your services elsewhere fast. The next use case on our list is using Kubernetes to get into tech. By running a couple of simple commands, you can have a Kubernetes cluster up and running, and from there you can start learning Linux concepts, CI/CD workflows, networking, and even application deployment strategies. Instead of being limited to theory, you gain a safe and reproducible playground where you can experiment, break things, and fix them again exactly how real-world experience is built. You can use small distributions such as Minikube, K0s, Kind, or K3s as they lower the barrier to entry by reducing the complexity of installation. Next on our list is machine learning workloads. GPUs are expensive and let's face it, they're often scarce. Kubernetes makes sure they are used efficiently. With specialized device plugins, it intelligently schedules GPU or TPU pods only on nodes that actually have the necessary hardware. Then by using tools like Kubeflow, you can bring entire ML pipelines, interactive notebooks, and models serving all under one unified roof. Need to train a massive large language model? You can spin up 256 GPU pods, let them crunch data for hours, and then scale them back to zero when the job's done. When OpenAI style shops need burst capacity for training or inference, they rely heavily on Kubernetes to orchestrate thousands of GPUs across regions without needing a human to babysit each one. It's about getting complex, resource-hungry AI tasks done efficiently and at scale. The ninth use case is development environment standardization. If you are fed up with hearing it works on my machine, Kubernetes can easily help you overcome this, as you can easily get consistent environments, namespace isolation, resource limits to prevent one team's work from affecting the others, and easy environment replications by leveraging infrastructure as code. The majority of successful organizations create development environments that replicate production ones to enable developers to test their features in realistic conditions. The next use case is legacy application modernization. Many organizations still rely heavily on legacy applications that were not designed with cloud-native principles in mind. These systems continue to deliver business value, but they often have issues with scalability, maintainability, and integrations. And with Kubernetes, you get immediate quick wins like automated health checks, self-healing capabilities, and rolling updates without needing a full, painful rewrite. You shouldn't think about this modernization as discarding the old, but rather think of it as enabling for the future. The 11th use case is using Kubernetes for edge computing and IoT. Kubernetes is a natural fit for managing workloads in these distributed environments, and leveraging lightweight distributions such as K3s are specifically optimized for these kind of devices. From an IoT perspective, Kubernetes helps you manage the scale and diversity of your devices. With thousands of endpoints generating streams of data, you need to implement orchestration to ensure that updates, patches, and new versions can be consistently deployed across the entire fleet. The next use case for Kubernetes is leveraging it in multi-tenant SaaS platforms. This is traditionally a huge headache, but Kubernetes makes it manageable. And this happens because namespaces act like lightweight, isolated apartments within a single shared clusters. You can also use resource quotas to ensure that the customer cannot use all the CPU. Network policies prevent tenants from snooping on each other's traffic. And by implementing role-based access control, you ensure that customer A can't accidentally or intentionally delete customer B's secrets. You can also use Kubernetes for event-driven and serverless computing. Knative, built right on top of Kubernetes, lets you deploy functions that scale completely to zero when they're idle. They wake up instantly on HTTP request, and you pay absolutely nothing when your service isn't doing anything. You get millisecond cold start times, and you retain the incredible freedom to move to any cloud because at its core, it's still just Kubernetes. If you think about banking systems, it's pretty clear that most of them are using event-driven Kubernetes applications to process transactions, scaling from zero to thousands of instances based on the transaction volume. The next use case is implementing governance and compliance, and this is a big one, especially in regulated industries. Frameworks like Open Policy Agent or Governo let you write crucial rules such as every container image must come from our approved internal registry, or we don't allow any privileged containers in production. And you can use it in conjunction with admission controllers that enforce these rules at the time of deployment, giving auditors a single clear policy engine that applies consistently across all your Kubernetes clusters. Last but not least, media processing. The demand for digital content has increased significantly because of streaming platforms, online gaming, user-generated media, and even interactive events. Kubernetes plays an important role for your digital assets by orchestrating distributed workloads for tasks like video transcoding, image processing, and even streaming optimization. Now that we've seen the top 15 use cases for Kubernetes, let's explore how Lens Kubernetes IDE can help you with all of them. Lens provides a graphical interface that helps you visualize and manage all your cluster resources without needing to memorize every kubectl command. You can view all your namespaces, your pods, your services, and deployments in real time, along with their logs, events, and resource usage. Lens also offers powerful features such as an integrated terminal access, ability to attach to your pods, connect to their shells, and view their logs. It transforms abstract concepts into something that is tangible, and you can see at a glance pods getting created, scaled up, or even restarted when failures occur. By leveraging the one-click AWS EKS integration, you can easily connect to all of your EKS clusters based on the permissions you have, and you can also take advantage of built-in AI capabilities using Lens Prism. With Lens Prism, you get a context-aware AI assistant that enables you to solve issues faster, understand the root cause, and even help you learn Kubernetes faster. Kubernetes isn't just hype, it's the powerful engine behind resilient, scalable, and portable applications, from the smallest edge device all the way up to the largest cloud deployments. Whether you're using complex microservices, crunching massive AI models, or just trying to survive the next Black Friday traffic surge, Kubernetes gives you the powerful controls you need to thrive. It empowers you to build smarter, faster, and with far less stress. But let's be real, Kubernetes is powerful, but it's not the right fit for every workload. If you're running a small, simple app, or lack container experience, or have even strict resource limits, or you don't need even high scalability, Kubernetes can add unnecessary complexity and cost. In cases like static websites or low-traffic portfolio projects, simple options like S3 or GitHub Pages or Vercel make more sense. Kubernetes truly shines when you need scalability, resilience, and flexibility, but for personal projects, experimenting with it is still a great way to sharpen your skills for real-world use cases. And that's it for this one. If you liked this video, don't forget to like, subscribe, and ring the bell to get notified when new videos come up. I'm Flavius. See you the next time.